What's up, everybody? Moving on to the next section, we're going to discuss some strategies to solve limits. So far the strategies we've been using is graphing or a table of values. But what if we can maybe algebraically do some things where we can get the limit a lot faster? So the first strategy we're going to go over is direct substitution. And this strategy is the easiest of all the strategies, so I would not depend on seeing it on the test. It probably won't show up, but we'll go over it anyway. And direct substitution is basically when you can take a function and then just plug in that x value that you're finding the limit at, because the function is going to be continuous at that x value and around that x value. So usually what's going to happen in the tougher limits that we've already seen, you're going to get usually limits where the x approaches a value where the function is undefined at. And then you're going to have to use some kind of different strategy. Before we use graphing and a table of values, but we'll go over some other strategies in the next few videos. But the rare case where you can actually plug in that x value and the function is defined at that point, then that's what the limit is going to equal, and that's what direct substitution is. So moving on to our first example, we got the limit as x approaches 2 of x squared plus 3x minus 1, and notice how we can just directly substitute this 2 for x. So we'd have 2 squared plus 3 times 2 minus 1, so it'd be 4 plus 6, which is 10 minus 1, so the answer is 9. So the limit as x approaches 2 of this function here is equal to 9. And actually a general note I want to make about this is that notice that this function here, x squared plus 3x minus 1, is a polynomial with a degree of 2. And whenever you're asked to find the limit of a polynomial, and f of x is a polynomial, that just means that the limit as x approaches a of f of x is equal to f of a. Meaning because a polynomial is always continuous, the limit as x approaches a certain value is always going to be equal to f of that value. So in this case, the limit as x approaches 2 of x squared plus 3x minus 1 is equal to 9. And if we plug in 2 for x, or f of 2, it's also equal to 9. So both of those are the same. So just remember that whenever you have a function that's a polynomial, you can just directly substitute that x value. Moving on to the second example, the limit as x approaches 3 of x cubed plus 2x minus 1 all over x squared minus 4. And notice when we plug in 3 for the x's, we directly substitute it. The denominator is not going to equal 0 because we'd have 9 minus 4, which is 5. So we know that the function at this x value of 3 is defined, so we can just make a direct substitution. So subbing in 3 for all the x values, 3 to the power of 3 is 27, plus 6 is 33, minus 1 is 32, and then 3 squared is 9, minus 4 is 5. So that there is our final answer. That's the limit of this function as x approaches 3. If you want to write it in decimals, it would just be 6.4. Similarly, for this question here, the limit as x approaches negative 3 of a function that's square rooted x to the power of 4 plus 3x minus 8 all over x squared minus 2x plus 1. Notice if we plug in negative 3 for the x's in the denominator, it won't equal 0. So we know that this function at an x value negative 3 is defined, so we can just use direct substitution and substitute that x value negative 3 for all the x's. So then when we actually evaluate it, when we evaluate the numerator, it would be 64. When we evaluate the denominator, it would just be 4. 64 divided by 4 gives us 16, and the square root of 16 is 4. So the limit as x approaches negative 3 of this whole function is equal to 4. So direct substitution is pretty easy. You're just pretty much subbing in that x value for the functions as long as the function is defined at that point. Now, a final point I want to make about direct substitution is that it doesn't work with piecewise functions. So if you're given limits with single functions and you can directly substitute that x value without the function being undefined, then that's what the limit is going to equal. But as I mentioned, don't depend on that. That's probably going to come up maybe one question on your test. It's very easy to do. Usually you're going to get limits where the x value, if you plug it into the function, is going to be undefined, and you're going to have to use some kind of other strategy, and that's what we're going to go over in the next few videos. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.